do you got? Any grief?
Yeah. I'm worried about not having the data.
Not having the, oh, you're going to have plenty of data. You just can't have the population data. You're going to have sample data. So here's, thank you. No, don't worry about not having data. You're going to have data, oh, I promise you. You're going to have data. Also, if you don't mind the lights, thank you. I promise you, you're going to have data. Matter of fact, one of the first things I'm going to do in a couple of weeks is hand you a couple pages stapled together of data sets that we're going to be playing from. The idea is, what can the data sets tell you about the populations they're drawn from? Sometimes nothing, sometimes maybe something. But don't worry about that. We're not going to be conjuring stuff out of thin air. I promise you that. I promise you that. So, speaking of which, you guys look exhausted. So, make a deal with you, probability. I'm going to have you draw cards. And the first person that can draw a red card from this deck, as soon as somebody draws a red card, you're out of here. Here's a question. On average, how long is that going to take? On average, how's that going to take? Well, that's a good question. Let's make it an easier question by the first person that draws a card, I'm going to put that card back in and shuffle up if that card comes out black. So if somebody has to redraw a card, I'll put the original card back in to keep the probabilities easy to calculate. Because otherwise, it does get tricky, doesn't it?
Are you taking out the red cards every time?
Whatever card, as soon as somebody pulls a red card, you guys are out. So if you see a red card come out, you're done. Boom. So Austin, let's have you draw first. Okay, I already shuffled them earlier. Yeah. Here's your population, which you can't see. Okay, boom. 5 of spades. Okay, what was the chance of pulling? What's the chance of pulling 5 of spades? The 5 of spades. 1 in 52. Let's write that down. Let's write that down. Probability. 5 of spades. 1 in 52. But that's a little too, like, precise. We don't care if it's a 5 of spades. We don't even really care if it's spades. What do we care about? We care if it's red or black card. So what's the chance of a black card?
126.
A black card.
1 and 2.
1 and 2, yes?
Yeah.
Think about the deck of cards.
26 and 52.
You get 26 reds, hearts and diamonds, and 26 black spades and clubs, right? So it should be a 50-50 shot.
Are there jokers?
I pulled the jokers to make it a little bit easier. I didn't want to have the, who asked that question? Thank you for that question.
I did.
Thank you, Rory. I didn't want to make it the American roulette wheel question. You know the American roulette wheel is bastards. Look at a roulette wheel in Vegas, and you want to go and bet on red. You're like, I don't bet on red. It's 50-50. No, it's not. They just put 2 green spots on it. You ever seen that? You've never seen roulette.
Double zeros.
Double zeros and single zeros. There's a single and a double zero. Yeah, bastards put 2. I think 38 total spaces. There's 18 red, 18 black, and 2 green. And that shifts it just enough below 50-50 to make Vegas.
They're making money.
It's craps all over again. It's a little bit worse than craps, actually. The English roulette wheel only has 1 green space. Over there, they don't care so much. It's 37 spaces instead of 38. All right, beautiful. So if we know that, on average, how long will it take us? How many cards should it take us on average to pull until we see a red? 3. I gotta vote for 2. 3. Vote for 3. I love this. Could you figure it out if you needed to? Could you figure out, on average, how many cards it would take us to pull? Could you? Do you think we can figure it out? Now, what? Cassie's like, I think I could. I think I could 2 weeks ago, but then I had spring break and now it's all gone. This is totally fun. What could we make and then find the average of? Yeah. What's this? What's this? I love this. Yes. Yes! Oh, Linda, making me happy. We could make a distribution, couldn't we? And then average the distribution, where x would be the number of times until we saw a red card. Let's make that in English so we can actually read it, huh? That's terrible. X equals number of times until a red card. Okay. And then the probability would be how likely it would be to take that many times, yes? So let's suppose, how likely would it be to grab the red card on the first pull?
0.5.
It'd be 0.5, wouldn't it? It'd be 1/2. Half half of them are red. So you grab out, there's a 1 in 2 chance that it should happen on the first pull. The problem is it might not happen on the first pull, it might happen on the second pull. Like Austin just pulled the 5 of spades, right? 5 of spades. Maybe it takes 2 pulls to see the red card. What's the chance of it?
For every card you...
Yes.
Yeah.
What's the chance of it taking 2 pulls before we see the red card? Anybody have any idea?
Depends on how many cards you already pulled out.
Well, I'm putting them back in. That's why I put them back in and make the math easy.
Okay.
Let me hear some ideas. I hear it over 1/4. Jolie, tell me why.
That's a good question.
I agree with it.
Multiply the house together.
Go.
Don't you go, yeah, 3/4, so then it's like half of whatever the previous
Yes!
probability was?
Because think about it. If it took 2 pulls to see the red card, what had to come out first? What's the chance of a black card coming out first? A half. What's the chance of then a red card coming out next? A half. It's a half times a half. There are 4 things that could happen. There are 4 things that could happen if you pull 2 cards. Black, 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 red, red, black, red, red. Is that fair? Each of those outcomes happens 25% of the time. But only one of them is talking about what happens right here. That is black followed by red. It's 1/2 times 1/2. Yes. Very nice. It's 1/2 times 1/2. Which is 1/4. I love that. Good question. Why? Good question. You had it. There was an intuition there about the 1/2. Could it take 3 pulls, maybe? Could it take 3? It could. What's the chance it would take 3 pulls? I hear go for 1 in 8. Because in order for it to take 3 pulls, what has to happen first? Black card. What has to happen second? What has to happen third? Red, right? Because if it's going to take 3 pulls, you're done at 3. So it's going to have to be 1/2 cubed, or 1 in 8. How about 4? Maybe 4? 5? 6? It's getting a little ridiculous now.
Those are direct cards in a row.
Say that again.
You have, or yeah, then what you're doing is direct cards in a row. Or
Well, in order for it to take 5 cards until we see red, you have to get 5 black pulls first,
okay,
and
so
then
you're saying until we see red, there's a 1 in the 32nd.
yes.
1 black.
In other words, it is a 1 in 32 chance of us taking 5 cards to see it. If we're pulling. This is a distribution I never really made you guys study in 243, unless you did the Gambler's Ruin quiz. Did anybody do that quiz? Only like 3 or 4 people did it, which was unfortunate because I had a lot of fun making it. The idea is, what's the maximum number of times it's going to take until you see red? Oh my God! Is there a maximum on this column?
No,
Is there?
There's not.
Oh, no.
If we're putting them back in, right, there's a maximum if I pull them out. Then the max is 27, of course. Because you could pull all 26 black cards out and then you're done. Then the 27th card has to be red. But since I'm putting them back in, it's infinite, isn't it? So in order to create the distribution, the average for this distribution, you'd actually have to have an infinite number of outcomes down the X. But I'm here to tell you that you see how small 1 in 64 is? What's the next one going to be? 1 in 128, 1 in 250, and so forth and so on. You don't have to go off to infinity if you don't want to. I think we have enough right here. Who's got the TIs with them right now? I think I brought mine. Could we find the average of that distribution as it sits right now? Find me the mathematical average of that distribution. So go in L1, 1, 2, 3, 4, 5, 6. In L2, 1/2, 1/4, 1/8, 1/16. While you're doing that, I'm going to do it by hand. See if I can come up with somewhat of. I'm going to close the camera off for a sec. That thing moved on me, bastard.